So this demo is about binomials. So binomial problems, you have two options and you don't have a choice really. The problem in your homework either wants you to use a binomial calculator or the normal approximation. I don't know, does approximation have one or two p's? I'm very sorry, maybe I'm spelling it wrong. But I think you should always use a binomial calculator because this is the 21st century, but textbooks still want you to use the normal approximation for certain questions. And so in that case you have to watch for bin issues, the bin edges, and you have to make sure you have a minimum NP and NP prime and all this other kind of stuff. So it's very, very complicated, lots of warnings, but you have to be careful so that you know which question to do with which tool. I'm going to just pull up both tools for a second. Ignore that. Stat calculators normal is right over here. Hopefully you know that. And then stat calculators binomial. Okay, so they're very, very similar, and many times you can get away with using both of them. So let me just make up a problem. Let's say I'm going to throw 100 coins. Each one has a 50-50 chance of turning out heads, 50-50 chance. So, but you can go between 0 and 100. That's 101 possibilities, not 100 possibilities, right? So we could also just find out what's the probability of rolling exactly 50. So we can just say something like this: 50 to 50. What's the probability of rolling exactly 50 heads? Well, it's about 8%. And we can use our binomial calculator either as standard. This is one tail test, and here's your options. Oh, I guess I could have done on the standard one, I could have just said equals, and I would have gotten the same answer. It's a little harder when you're doing the normal approximation. I'm going to pause this for a second to do the calculations for you. Okay, so we had 100 coins, so that's my n value. Probability of heads is 0.5, probability of tails is 0.5. So usually p and p bar aren't the same, but 1 minus 0.5 is 0.5. So there we've got it. Expected value is 50 heads. Standard deviation, so you had the the n, the p, and the p bar, multiply them all together, take the square root, because 0.5 times 0.5 is 0.25, so we got off really easy this time. Perfect square inside the square root gives us a 5. Okay, so we're going to use this information to load up this guy here. So the mean expected value is 50 and the standard deviation is 5. And we want to do between what and what. If we want to know what's the probability of getting 50, we have to actually turn this from a continuous measure into a discrete measure by adding a little bit on each side. So we have to add half of the bar on the left of the 50 and half the bar on the right of the 50, and then we're going to get the same answer that we got over here in binomial calculator. It's very, very close. Okay, it's close enough that yeah, hopefully if you're only chopping off 3 digits for StatCrunch, then it doesn't really matter. But there are questions in, sorry, I meant Pearson. There are questions in the Pearson set where if you use the binomial calculator, they will give you the wrong answer. So if you're using one of these tools and you get the wrong answer, just switch to the other tool, because it's not worth spending hours figuring out what's wrong when they're just expecting you to use a different tool. So hopefully that helps and you can see how this tool works. And don't forget, if you need to use the approximator here with the normal calculator, don't forget to add your edges on.